All right, let's roll. Day 7. Kids at home, let's roll. Day 7. Got to 1 o'clock if you didn't have an opportunity to hand it in. All right, here we go. Day 7. We already got 4 methods of proving triangles congruent. Here's the 5th one. And I saved it, and I save it for 1 day only. All right, because it's a pretty special way. You will notice there are no S's or A's in this way. It's an H and an L. An H and an L. The H stands for hypotenuse. The L stands for leg. Hypotenuse, leg is your 5th and final method. Hypotenuse, leg. No A's, no S's. All right, I took this for granted in my first period class, and I can't do it again. When you have a right triangle, do you know where the hypotenuse is located? Because nobody knew. It was like foreign language to my first period kids. And don't tell me the longest side, because I'm probably not going to give you the side lengths. Where is the hypotenuse located? No matter if I do the triangle like this, if I do it upside down, doesn't matter. Where is the hypotenuse always located? Lucas? Across from the right angle. The hypotenuse is always located across from the right angle. And what are the other 2 sides referred to as? Those are called my legs. The sides that form the right angles, okay? So I just wanted to go over that little brief history of a right triangle. Now you guys know what HL is now, okay? HL, you need to have the hypotenuses?
Hypotenuse?
Anybody?
Hypotenuse.
Hypotenuse? I don't know. I've been doing this for 18 years and I still haven't found out. Hypotenuses, hypotenuses, what do we think here, guys?
I'm thinking hypotenuses.
Hypotenuses or hypotenuse?
If it ends with an N,
it's kind of like, what's the plural of rhinoceros?
Rhinoceros ends in an N.
Rhinos, get with it, all right? Rhinos. So what are we going with? Hypotenuses or hypotenuses?
I go for it's hypotenuses.
It's hypotenuses?
Man, that's a
Okay, all right, that's fine. We'll go with hypotenuses. So if the hypotenuses, take a look at my diagram. If the hypotenuses are equal, and you have a pair of legs equal, the triangles will be congruent by a method now known as HL. HL. Because if I had given you this diagram last week, why isn't this side angle side? Why isn't this congruent by side angle side? What do you notice about the right angles? They are not in between the segment, in between the sides. So that's that side angle side. So what I'm trying to get to you guys is HL only works in one type of triangle, and that's a right triangle only. That is it. You can't pull HL out of any other triangle but a right triangle. And you guys have a note at the bottom, and I'm not going to rewrite this, but just take a look at that note. Okay? That note says you must have right triangles in your statements too. Before I write down 2 triangles are congruent by HL, you need to write somewhere in your statements that those 2 are right triangles, and I'll explain why here in a minute. But everyone good? HL only for right triangles only. Now, does that mean that you see right triangle, you think HL? No. Are you kidding me? Ready? Let's go back to my diagram here. Are those triangles congruent?
Yeah.
Not by HL. By what method though? Angle, side, angle, right? Everyone agrees that's angle, side, angle. Do not get in the mindset, I see right triangle, I see HL. That's not the case. Are we all good? All right, let's focus on HL though today. What do some HL proofs look like? Go ahead, mark up your diagram for number 1. Write whatever you got to write in. All right, so I got ABC and DCB are right angles. Got it? AC congruent to DB. Got it. All right. I don't want to write anything in yet. I want to take a look at both triangles to show you where HL comes into play. All right, I have right triangles, right? Everyone agrees, right triangles. That doesn't mean HL though, not yet. What did I give you congruent? CA and DB, those are the what? What did we just call those? Those are the hypotenuses. Everyone agrees? So I have the hypotenuses. Can you do anything else on the diagram? I hope so. What else can you mark? Ellie, what else can you mark? CB. And CB is a what of each triangle? Not the hypotenuses. That's a leg. Now, here's the question. Is this side angle side? Would this be side angle side? And if you're going to say no, tell me why. Why isn't this side angle side? Go ahead, Audrey.
The angle is
You settle down at home, all right? You'll get some action in a little bit. Go ahead, Audrey.
Because it's not between the two sides.
The angle is not in between the two sides. But do you see the HL, though? H right here, and you don't have to mark this. H, L. We all good? All right, so what's got to go in my proof? I now know it's an HL proof. What else still needs to go in? Well, Ellie, you told me the reflexive side, right?
Yeah.
Okay, so Ellie told us, hey, you got CB equal to itself. That's got to go in there. Reflexive. All right, let me turn. What else do you think has to go in here? Okay, I got the AC and DB. Those were the hypotenuses. CB, CB, there's the leg, but you're not ready to say the triangles are congruent by HL yet. We still got to put a little more in there. What'd you usually say about those two? What'd you usually have to say all last week, and since we've been doing proofs about right angles? Yeah, then you got to tell me they're congruent, right? But whoa, hold yourself. Hold it. This method is called what? HL. Anybody see any angles in there? In HL? No. So, in an HL proof, you do not have to tell me the right angles are congruent. If you do, it's still okay. Okay? It's still okay if you do. It's just an extra step that you didn't need. Everyone good? Okay? In an HL proof, I don't need to tell you the right angles are congruent. I do need to tell you they are right angles, but you don't need to tell me they're congruent. What I do need, though, and this was at the note on top, if you use HL, you have to state what triangles are right triangles. So in step 3, I need to tell you triangle CAB and triangle DBC are right triangles. In an HL proof, you have to tell me what triangles are right triangles. And the reason? Don't use definition of right triangle. When you're telling me something's a right triangle and you're telling me definition, that's not going to do any good. Instead, how do we know it's a right triangle? Oh, right triangles have right angles. Okay, right triangles have right angles. Okay, I got the hypotenuses, I got the legs, I got the right angles, and I got the right triangles. We're good. Now in step 4, you do have enough information to say triangle ABC is congruent to triangle DCB, little thing we like to now call HL, hypotenuse leg. Questions there? Yes, Sophia.
Say that it's all right if we do say the right triangle or right angle are congruent, even though it's
Yeah, that's fine. It's still a correct step. That's fine.
probably gonna do it out of habit.
Yeah, that's fine. I probably prefer that you just keep doing it every time, no matter if it's HL or not. Any other questions? All right, one doesn't make you great.
I said that to my little sister the other day.
Darn right. Quickly, look at the proof statement. We're proving segments, which usually means, okay, if I'm proving segments, I still got to prove the what congruent first, though, before I show the sides. I still got to prove my what congruent. Oh, boy. This is what we did on Thursday. If I'm going to prove sides congruent, you still got to prove the what congruent first. The triangles, yes. All right, this is going to be what at the end? What's going to be I already know what's going to be my last reason here. CPCTC, right? CPCTC, but you still got to prove triangles congruent. Let's do it. All right, what do I got here? CD congruent to EA. Boom. Oh, how about this vocabulary term? Oh, I love it. AD is a perpendicular bisector of CE. That's a lot. Well, let's take the perpendicular part. What are we forming? Right angles where AD and CE meet. So we're forming right angles here. Not only is it forming right angles, but CE is getting bisected. I'm going to need somebody to tell me a pair of segments up here congruent now. CE is the one being bisected. Name a pair of segments that are equal. Radhika, I told you you're going to get your time. Got a
CB and BE.
CB and BE. Yep, are congruent by being a bisector. Good, being bisected. Look, guys, please look at the triangles you've marked. Please look at the triangles you've marked. Is it side angle side? No, the right angles aren't in between. But, ready? Are the hypotenuses congruent? A pair of legs congruent? Do you have a right triangle? All right, put it all together, it equals HL. You just got to tell me what do I need to put in my diagram, because we've marked this diagram beautifully, but as you guys know, you get no credit for your diagram. You get credit for what's in here, the statements and reasons. All right, here you go. Tell me one thing that's got to go in. Let's roll here. Caroline, again.
CB is congruent to BE, definition of bisector.
Yep. All back together again. One big happy group. Oh, it's great, isn't it? What else needs to go in your proof? I got the bisector in there now. Let's keep going. 11. Let's roll. Anthony, what else got to be in here?
CBD is a right.
Go.
CBD is a right angle and ABD is a right angle.
Yep. Got to tell me they're right. You don't have to tell me they're congruent, but you need a right angle so you can tell me they're a right triangle in a minute. CBD and ABE are right angles. Perpendicular lines form right angles. You could also have definition of perpendicular bisector. Form right angles. Okay, can't say HL yet though. HL only works for what type of triangles? Right triangles. So you got to be in the habit. If you're going to use HL, tell me what triangles are right triangles. So triangle ABE and triangle DBC are right triangles. Right triangles have right angles. Now you can tell me they're congruent by HL, and we're still not done. Be careful when you write it. Anybody remember why? When you write these two triangles are congruent, what do we got to make sure of? Sophia, what do we got to make sure of?
The letter order is matching.
Order of the angles and sides matter. Yes, it matters. So somebody give me a quality congruent statement here. Quality triangle congruent statement. Yes, you will. Will, going home. Give me a quality one, Will.
Triangle ABE is congruent to triangle DBC.
That's quality. One of many you could write, guys. One of many. By our method today, HL. That's not what we were asked to do, right? If the triangles are congruent, so are any corresponding sides or angles, including side AB being congruent to side BD. Oh, here we go. Have we been practicing it? Why are the sides equal? Oh, let's hear it. Let's hear it, Ryan.
CPCTC.
Oh, let it roll off the tongue. Kid's been practicing this weekend. CPCTC. Good job. So you guys, again, you see proving sides or angles, automatic, CPCTC, but you got to prove triangles. You guys all right? We okay? I'm going to do one more with you. Last one's on your own, okay, to see where you are. let's do number 4 together, and I'm going to let you do 3 on your own. Okay, so everyone skip over to 4. Skip over to 4, you kids at home. Wow, first, can we just acknowledge that proof statement? We have never seen that before. Ooh, what am I asking you to do here? We can prove sides, we can prove angles, we can prove triangles, but bisects? Yikes. All right, go ahead, mark your diagram, then we'll talk. Mark your diagram, kids. You got BD and AD. Make sure you put the right angle symbol in the proper spot. BC and AC. Make sure you put the right angle in the proper spot. BD is congruent to BC. Okay. Anybody else putting another marking on? I think we're beyond this point, but I'll still ask. Anybody putting other markings on their diagram other than the ones I have? Sabrina, any other markings on your diagram, Sabrina?
AB is congruent to AB.
Yep, good job. All right, so I got that right there. Let's go to the proof statement now, please, because we got to make a plan here. How are we going to show that AB bisects DAC? How are we going to show that? Well, let's. Oh, you want? I'm going to go ahead. You want a suggestion? That's fine with me. I don't
You
want.
can prove that DAB is congruent to BAC.
Okay, hey, perfect. Here's what you just said, basically. Hey guys, if you knew this was true, if angle DAC was getting bisected, what 2 angles would be equal?
DAB and DAC.
DAB would be congruent to CAB. Everyone agrees there?
Wait,
If
DAB, not DBA.
what?
No, I misread. Am I misreading something? I am misreading something. Sorry about that.
Don't stop the train.
Sorry.
Get off the track, Sophia, when the train's coming through. Okay? Yes, I have those. If you can show me these 2 angles are congruent, AB's got to bisect that angle. Can you do it? Do you have enough knowledge to prove 2 angles equal? Yeah, you do, by proving the what first, though? You can't get to the angles congruent unless what else is congruent? The triangles, yes. Can we get the triangles congruent? At home, can we get the triangles congruent? Side angle side? Side angle side? No, that right angle's not in between. It's going to be HL. Tell me what I got to put in my proof. This is going to be a long one. This is going to be your longest proof yet, so buckle up. Woo. Gideon, name one thing that's got to go in my proof. I've marked my diagram beautifully, but I put nothing in my proof yet.
AB is congruent to AB.
Oh, he took the easy way out first, didn't he, guys? He took the easy way out. Reflexive first. All right. What else has to go in there? Woo. Let's hear it. Lucas, we're getting fired up. Somebody's getting fired up at home. Lucas.
Triangle DAB and triangle BAC are right triangles.
Why are they right triangles?
HL.
Okay, we're getting good. HL.
Because they have right angles.
Where? In the diagram they do. Where do they need to have right angles?
Oh, in the proof.
Yeah, so I need to say the right angles first. All right, everyone good? Diagram doesn't matter to me. It's got to be in the proof. So tell me angle, I got to call that angle ADB and angle BCA are right angles. Perpendicular lines form right angles. Yes, sir. Here we go. All right, now I'll just go to what Lucas, I know, I think we're ready. Yeah. Now I can say triangle ADB and triangle BCA are right triangles. Reason, same reason every time. Right triangles have right angles. Do I have everything I need, guys? I think so. I think they're good to go. They're congruent now, right? Maybe I was lying. I thought it was going to be 8 steps, but no, that's the next one coming up. So now I could say triangle, make sure I get the order right here. ADB is congruent to triangle ACB. That's HL. What was our goal here? We're not ready for the proof statement yet. Why did we want the triangles congruent? Quincy?
To prove angle DAB is congruent to angle CAB.
All right, I got the triangles to say those angles. DAB congruent to angle, what do we got? DAB, CAB? I just want it so somebody can say it. Why are those angles equal? Oh, let's hear it. Let's hear it, Atticus.
CPCTC.
There it is. Let it roll off the tongue. CPCTC. Got it. And now going all the way back to where Omni started with us. Hey, if the angles are congruent, that must mean they're getting bisected by AB. So AB bisects angle DAC. But we got to talk about a reason, because definition of bisector isn't going to cut it. Why are you sitting in a chair? Mr. Carlino, that's the definition of a chair. Doesn't tell me anything about a chair, right? How do you know they're being bisected? Quincy?
Bisectors form congruent angles.
That's fine. Bisectors form congruent angles. Or actually, what I'm going to do is write out what angles are congruent for me. What did you just prove in step 6? Angle DAB congruent to angle CAB. Or bisector cuts two angles, or cuts an angle into two congruent ones. Fine. Anything but just writing definition of a bisector. Everyone okay on that one? Okay, hands are off now. You guys got number 3. I'm just going to write my version up as you're doing it. Same thing at home. You guys got number 3 now on your own. You're trying to prove angle 1 congruent to angle 2. Get in the mindset. Angle 1 and 2 aren't equal until what are equal? Angle 1 and angle 2 aren't congruent unless you prove the triangle's congruent. Good job, everyone. Good job. So you got to find a pair of triangles that contain angle 1 and angle 2 and prove them congruent. Because you know this is going to end with CPCTC somehow. Oh, this one's going to get tricky. Just so everyone realizes, when they give you BE is congruent to BF, congruent to DE. When they give you BF and DE, that is not a side in the triangles I need. All right? That's not a lot of you guys did that on the quiz. You just assumed that that was meant a pair of sides. Those are not sides in the triangles you're trying to get congruent. You can use that to get a pair of sides, but it is not a pair of sides. BE and FD are your sides. How many of you are forgetting to say the right triangles? Shoot. Eight-stepper. Whew. Congratulations.
Is there any way we'll be able to tell when we look at a group whether or not we need to do HL or like when it asks us to group segments or angles? Is there any way for like any way that anyone puts off that, okay, we need to do CPCPC instead of just finding a way to make the angles congruent?
It's going to probably be CPCTC at the end. That's it. Unless you can get two pairs of angles and do third angles theorem. But most of the time it's going to be prove the triangle's congruent, so you can say CPCTC. You guys at home, anybody here have questions with this proof? Did we see the subtraction? Did we see it? Some of you guys missed that on the quiz. Okay, you missed the subtraction part. Those are not full sides that I was given. I had to make them smaller, so I needed to do that by subtractions. Everyone's all good? Questions at all? You guys at home, how we do all right on this one? Okay, tonight's homework's not bad. 3 questions where you got to tell me the method and 1 HL proof. That is it. Oh, can't wait to see you guys tomorrow at home. Can't wait to be back together again. Hopefully you can pick up the sarcasm in my voice. You guys have a good night. Behave. See you tomorrow, some of you.
Are we on the practice field?
Game field.